fully understand it's just before lunch, so I'm going to try and keep this quite light. My slides do not have a lot on them, but we will be producing a white paper outlining some of these lessons in the next couple of days or week. So, APIMetrics, we're a monitoring company. We monitor APIs for a variety of companies, not just banks, but we have been monitoring production open banking APIs for large UK banks since the outset of open banking there, which I think the first cut was something around 2019 when they had to go live with them, and they started to find out some of the challenges that Dinesh touched on around regulated APIs with strict standards. But it was the first time for a lot of them opening up their IT stacks to third parties, and that created a lot of issues. So we've been monitoring the APIs, we've been monitoring how they work, and essentially if you want to think about what APIMetrics does for them, we're a trusted third party in every cloud data center running against production accounts in the way that they would be called by a third party. Since we started doing this for banks, regulators, and others, we've run about 30 million sample transactions across all of the major clouds in Europe into real live bank accounts in the banks. And what we do is we gather the data and we normalize it, and we show where there are potential problems. And along the way, what I'm going to talk about are the problems that we've encountered while doing it, and some of the gotchas we've found that people keep hitting over and over again as they roll out open banking solutions and have to work with third parties. So, one of the findings we do have, which is interesting but not necessarily surprising, is part of our technology, we score the quality of APIs. We invented our own scoring system. We call it CASC, and it's essentially like a net promoter score. It's out of 10. 10 is perfect. Nobody in the real world is perfect. Anything below about 6 is terrible. And what we wanted to do, it gives us a way of categorizing APIs against each other, either by the organization providing them or the API type itself. The green line through the middle is the average of the best APIs in the industry. These are the top performing enterprise APIs that we monitor as a side project. So this is Office 365, Microsoft Teams, Google Workspaces, DocuSign, Box. It's a bucket of about 20 different APIs, and their average score is about 8.6, 8.7. And that's incredibly consistent. The design of the score is for consistency. We don't expect it to move around much. We're not grading on a curve. We're just measuring the overall quality. And if you're looking at the big providers who've been doing this for a long time, whose businesses rely on APIs, that almost never changes. That line would be a little bit wobblier, but not a lot. So the first thing you'll notice is the banks are a little bit more up and down than that. We took the 35 lead open banking providers in the UK. These are regulated entities operating to the open banking implementation entity rules. And we've categorized them into 3 buckets. First bucket is the CMA9. The CMA9 are the 9 largest banking entities in the United Kingdom. These are some global brands. It includes NatWest Group, who own Royal Bank of Scotland, and about 7 other banks. HSBC Group, which is part of HSBC Global. Barclays Bank, which is one of the oldest in the country. Santander Group, Spanish banking group. A bunch of Irish banks, and a couple of others. The next group is what I will call the traditional banks. These are traditional banking entities you will almost certainly never heard of here. So Cumberland Building Society is one of them. Yorkshire Building Society. These are savings and loans. They're tiny institutions. They don't have a lot of IT heft, and they're somewhat struggling. But also in there, we've got some old-style credit card companies. The gray line at the top are the neobanks. These are the TrueLayers and the entities that have created themselves to do banking in the modern era. As you may notice, from an API quality perspective, they are doing the best. So they have created shiny new architectures using the latest technologies that just work, and they do work very well. The blue line is the average, and you'll see that the big entities track the average pretty well. The big entities do have some challenges. They Some of our customers have API or have database architectures older than me, and I'm not very young. So they are having to integrate into very old stacks, and they can fall over in weird and entertaining ways, and they're not necessarily ways that they can track with modern DevOps tools. So they're often caught out by the fact that something has gone down, and it's gone down in a very creative and cunning way. The yellow line are the traditional banks, and they really are the ones that are struggling. One of the reasons for this dip here, that kind of affected the entire average, one of the building societies was down hard for nearly a week and a half, bridging 2 months. And they went dark and they couldn't get it back up. And their entire IT department and their IT spend is a fraction of any of the others. And it's marked to us that impacts everything that goes on. So what I'm going to talk about are some of the lessons we've learned from setting up on a lot of these entities, working with regulated APIs, and some of the other challenges we've had. So, lesson 1, Quicksand. When I was a kid, I grew up watching a lot of Tarzan and Saturday serial movies. I thought Quicksand was going to be a much bigger risk to my life than it turned out to be in the 2020s. However, sandboxes turned into the bane of our lives. It was a regulatory requirement of British open banking that each bank provides a sandbox. They were forced to provide the sandboxes 2 years before they had their open banking system set up. Consequently, the sandboxes did not work. They did not represent anything in particular related to the open banking architectures they went with. They didn't use the same security. They sometimes didn't even use the same types of APIs, and they didn't use the same syntaxes. So what a lot of organizations found is they could be up on the sandbox and think, great, I've got the sandbox working. Try and roll out their open banking implementation, and none of it would work. And they had to go back to basics, which is where we learn some other lessons. But sandboxes are inherently useful. You should pay more attention to how well they work, and they should be part of what the other DevOps people do. That was the second thing we learned as part of this lesson. We've had a client whose sandbox has been down for 4 months, and they were complaining that we weren't monitoring it for them, and we kept telling them that's because it doesn't work, and they hadn't noticed. Even though we were telling them why it wasn't working, it was not high enough on their priority list until somebody actually went, oh yeah, you're right, okay, we'll fix that. So, sandboxes, pay attention to them, work with them. They are important to the health of the ecosystem, and they shouldn't be just there as an afterthought that you bought from a company that has nothing to do with your architecture. Ideally, and the neobanks are very good at this, use a stubbed-off version of your production environment, and don't build something completely separate. Second lesson was around documentation. It just doesn't work. We onboarded about 35 API providers. We did 17 or so of them in a day and a half. It was just bang, bang, bang. We downloaded the spec, we read the docs. They were all the same. It's a standard. It should just work, to go to Dinesh's point. The next 30-ish% of those took 2 weeks. We had to keep asking questions. There were problems with their documentation. You can have the greatest documentation in the world, but if you've put it in a PDF and there's a 256-bit string that you need to copy in for digital signing in that PDF, it's not going to work. It's going to lead to people shouting at computers and getting upset. The last group, which still to this day includes 3 of the banks, we've never got working. They're not responsive to support queries. They themselves don't seem to know what's wrong with their own API stacks, and we just gave up on the process. And that's been emblematic of a problem inside UK open banking. People don't understand how the FAPI security sequence works. They don't understand how some of the bits hang together. We've had to do a lot of hand-holding with the providers, and one of the entertaining things for us is, have they never considered getting somebody to onboard with their banks who doesn't work for them or doesn't know what everything looks like? One of the problems here can be the tooling involved. A lot of people use Postman. Postman generally works if you're testing things inside your stack, but a lot of the time you won't try and run external queries with it because of the security requirements on open banking. So, test what you do in a production environment with somebody who doesn't know it inside out, and you will learn some horrible things. Lesson 3. following on from people tend to test with tools that work inside their stack, the experience of using APIs is now an end-to-end distributed experience. Your third parties that you work with do not live in your data centers, do not live in your stack, they live in the cloud. This may come as a shock to everybody, but the cloud is not only AWS. There are other clouds. Some of the clouds are quite big, run by big companies. Some are quite small, where people have stuck things. Second thing that may come as a surprise, the clouds don't all work the same. They don't all work with your architectures the same. If you are on a private cloud yourself, your InfoSec rules may work great with some data centers, but not particularly well with others. We've seen as much as 2 seconds per transaction differences between calls made from Google and Amazon. We've seen differences of over a second between different Amazon data centers in the same geographical region because they're working with different standards, and they're working with different InfoSec interactions with the bank's data centers, particularly if the banks are using their own data center and not a public cloud one too. The final point, as my chief engineer likes to put it, is it's never DNS until it is. DNS is still a thing. It's very annoying. The number of times we've resolved a problem to the provider we work with bought a CDN, but didn't realize their APIs automatically were not configured as part of the CDN setup. And it just isn't in the same caching as the CDN. Also, some of the cloud data centers don't know where locations are, or even where they are themselves. Naming no names, Microsoft, they have a bad reputation within Azure for assuming every Azure data center is somehow in Redmond. They do work very hard on this, but there is a tendency, if they spin up a new block of IP addresses, the IP addresses don't necessarily map to where they are in the world, and that can lead to some very peculiar routing decisions. When they get it right, they're very, very good, one of the best in the industry. When it goes wrong, everything will be going through Seattle and back. So it's just something to be aware of when you're setting things up, that all of these steps need to be thought about, and nothing beats measuring from where your partners are. And a lot of what we do for banks is about measuring from cloud data centers where trusted third parties are operating from to tell them what something's going to look like for that third party. And that solves disputes where they all sit in a room with the Financial Conduct Authority in East London, screaming at each other when both sides bring proof the other is wrong. It often turns out that both sides have a point, but if they have to look at it in the same way. There's something I'm talking about this afternoon, that one of the challenges for the industry in general is we don't have agreed standards for how we measure things and what we do around measurement. Lesson 4, this is a challenging one. I'm going to ask my friend Dr. House to help me here. Everybody lies. DevOps teams lie to each other to, I wouldn't say cover their asses, but to make things better for themselves. They lie to their management. Tools lie to you to make you feel better about yourself. They lie about HTTP codes. Everything needs to be looked at in far more depth than it is. And one of the lessons we've learned is you can't just rely on a 400 code being someone else's problem. An anecdote from an experience we had with a customer, their consent server broke. They had a massive outage. It didn't last very long. We alerted them. They had a series of 500s. They fixed it. But because of the way the consent server broke, they lost the consents for the API, for the production accounts that we were monitoring. Because that manifests itself as a 400 error, that was not escalated through their internal triage processes because, it's 400, it's not my problem. So they were down for a week because they couldn't persuade anybody internally in their triage escalation process that actually it was a serious 400 because everybody was pushing it around to different groups without realizing, well, actually, we can't monitor our systems. Now, technically speaking, you could argue that 400 was perfectly correct. They were, in fact, returning the right code. But we see situations where the 400s are actually functionally wrong. We have seen passes from APIs with zombie tokens where you use a token that should have expired and suddenly it starts working again and nobody knows why. But that's a huge security hole. We see scopes that shouldn't work working. We see failures of authentication when no failure happened, and a call made using exactly the same scope and token a few seconds later works perfectly. Those are things that need to be looked at and they need to be considered. But if you just rely on gateway logs and looking at what the codes are telling you, particularly in a lot of APM tools, you'll often get a false sense of security around what's going on with your stack. And these problems rarely go away. They tend to build and escalate over time until the root cause manifests itself, and you'll have something much more serious to fix. The final lesson we learned is, and this is a problem with monitoring in general, and I will rant about this over drinks at the cocktail party later if anyone wants to hear it. Be honest to frogs, don't boil them. As the saying goes, if you put a frog in some water and start heating it, the frog won't notice until it's too late. The graph on the left is a situation where this is actually a live production accounts API from a major global bank. It wasn't very fast to start with. That's about 1 second per transaction. That's about 12 seconds per transaction. Over the course of 3 months, it got slower and slower. We told them around about there that there was a problem. And it started going down, and they ticked it off as resolved. Then it went back up again. The problem they found was the trend, it's almost a straight line. The trend warnings and thresholds they had set within their internal APM stack was almost perfectly tuned to miss that type of propagation. And they just didn't notice that everything was getting slower until it was really slow. And even then, they were assuming everything was fine because they would have expected to have an error or an alert sent to them by another system. But they hadn't had it. Other variations we've had on this are you set your threshold for alerting so high, and your API is usually very fast, that your API can be functionally down for several hours a day and it will never trip an alarm because you've set the threshold at 2 seconds and the API normally responds in 200 milliseconds. So it takes a lot of latency and a lot of timeouts before you actually get told. And we saw a cycle of tickets being raised on a Tuesday night when people couldn't use the API. And then Wednesday morning, someone would look and everything was working. Because Tuesday afternoons, a cron job ran that shut the server down to all intents and purposes. But they missed it for weeks. The other problem we have, and it goes to some of the other tools we've had today, if you use Splunk or other tooling and you're cheap or you've got vast amounts of data and you don't want to pay for the storage costs, some of these can drop off your internal logs before you realize something's gone wrong. And a number of times, because we have persistent storage, we've been asked to go back and tell them when something went wrong. And we'll tie it back usually to an event that happened around midnight on a given day of the week. And it's almost always you'll say, well, what did you do at midnight UTC on June 6th? Oh, crap. I know what we did. Because they had forgotten that they pushed something and they hadn't done any checking. They checked the build didn't break anything, but they hadn't checked that the build was performant. So, conclusion, open banking is working well in the UK. It is very performant, but a lot of them are struggling. Another trend we're seeing with open banking is regulators are asking the banks to mark their own homework. My plaintive request to regulators is stop asking people to mark their own homework. Particularly if you just tell them what you expect to see, they will tell you that. Neobanks are doing best, but it's been remarkable to us that the large banks, essentially through throwing money at the problem, can do as well as the neobanks on average. But it's really challenging for some of the traditional players. But the traditional players really need to kind of buck up or they're going to get rolled completely by the neobanks and the big banks. And I think there will be potentially a lot of consolidation there if they can't get it right, because people just won't use their systems. And existing monitoring doesn't always tell you these things. Anyway, I'm David O'Neill. If you have any questions, happy to answer them. I'll be around for the next 2 days as well. Thanks.
Excellent. Thank you, David. Thank you. We have time for some questions. Does anybody have any questions? Yes.
Earlier you spoke about Sandbox. Sandbox is in my day-to-day job, very near and dear to my heart, and we are not doing it right or wrong, so I'll leave it at that. I'm curious, what's your goal? What would be your goal of a Sandbox? Is it to mimic a QA environment, or truly just allow a third party to evaluate a service, understand, is this service for me? I know there's a couple couple, I guess, definitions of what a sandbox should be, but I'm curious what yours is.
This depends on the industry you're in, and open banking is interesting. If you're in an open banking environment regulated like the UK, where everybody in theory can sign up and become a provider and integrate, then you should treat it as an API first thing where it's beyond the QA environment. It's actual developers need to be able to sign up, get some kind of token, and build a solution that they could then switch out the test tokens for, or the test certificates, and then go to production on it. That would be my ideal. That's what I think. That's what we've been told over and over again by TPPs they want. That if they're building 30 or 40 or even 150 or 450, as it is in Germany, integrations to different banks, they want to know that they're going to work before they go live, and they're not going to have surprises. And that's what we have not. That has not been something people can guarantee from the UK environment. So I think it's less about the QA environment. It's more about does it use the same security? Does it are the syntaxes the same? Are the two kept in general agreement? Even if it won't fail the same way because it's using fake data, at least have everything so it functionally looks the same, rather than I don't want to rag on ForgeRock because they actually do a generally good job, but you just buy a Sandbox solution for ForgeRock and then you build your own system using MuleSoft or someone else. That just builds up friction in the industry.
Got it. Okay, makes sense. A lot of the headwinds we face is just investing in a sandbox that gets us close to production without just spending the same amount of money as building production.
So the neobanks, the Rails Bank, Railer, TrueLayer, some of the new guys who come along, or new providers who come along, they've gone at it from the point of view of they have one stack, and one talks to a fake backend, and the other talks to the production backend. And then when you switch to production credentials, it just gets shifted. I know that's difficult for traditional banks. We have this all the time. We use modern cloud infrastructures for things like backup. You wouldn't believe the pain we've had with InfoSec teams and risk teams inside banks explaining that we don't do a nightly backup and a tape drive sort of given to Sam, who puts on a scooter and drives across London or whatever. They genuinely cannot understand how everything is replicated in real time between data centers 500 miles apart. And when we argue with them on that, they go, well, what happens if Google loses both Iowa and Kansas? It's like, well, your APIMetrics monitoring is really not the biggest of your concerns if that happens. The asteroid that just impacted North America is going to cause many more problems for you.
Any other questions? Anyone? All right. Thank you very much, Dave. Thank you.